Here's exactly how I'm upgrading my cycloidal drive before it has to lift over 30 pounds. Today is day 42 of Learning Robotics. After building my first prototype, there's a couple issues that I need to fix before moving forward. The biggest issue is that my cycloidal gears aren't using all the space inside the housing. Both the top and bottom gears are using the same needle roller bearing. So I increased the spacing in the input shaft, and now the gears can spread out properly without grinding against each other. But there's another problem. My gears are going to be facing serious stress, which means my 4mm thick gears aren't actually going to cut it. So I need to order thicker bearings so I can create thicker gears. I could definitely spend a lifetime perfecting the cycloidal drive, but it's time to move on. So let's talk about the elbow joint. I just got this O-drive dual shaft motor, and my plan is to mount it directly inside the joint. The motor shaft will be a smaller cycloidal gearbox right there at the elbow, instead of using belts or external mounting. But here's the issue. My motor weighs nearly 900 grams, meaning I have to make sure my current cycloidal gearbox at the shoulder joint can support that kind of weight and the rest of the arm. So to double check, let's pull up my kinematics animation from my earlier videos and let's calculate the torque. Torque is basically rotational force, meaning the further away the weight is from the joint, the harder it is to hold up. I know I want my arm to be at least 3 feet, so let's just say that the shoulder to elbow length is around 1 foot and 3 inches. We know that the motor weighs 2 pounds, so that means that the shoulder joint needs to produce around 3.4 Newton meters of torque to even hold that kind of weight up. However, at 40 amps of continuous current, my shoulder joint motor only produces 3.3 Newton meters. That's cutting it really close, but you have to remember I have a cycloidal drive. My cycloidal drive has a 20:1 gear ratio. That means I get to multiply the torque by 20. This means that my output torque should be around 66 Newton meters. This means even at rest, my shoulder joint motor can hold 20 dual shaft motors. This means my cycloidal drive is more than strong enough and I just need to get the final version. But yeah, that's it. I'll see you tomorrow.